Welcome viewers. Today we are going to discuss three key elements of environmental study, that is geomorphology, environment and society. These three are interlinked and influences each other. Geomorphology is a very important aspect of landscape study. It integrates landscape structure, landscape potential and many environmental related development can take place using landscape study. And when we use by the environmental planners or decision makers, then it influences also the society. So, we are going to discuss taking empirical evidences from different parts of our country. The interdependent relationship between human and landscape is an important but a still underdeveloped concept in geomorphology. A detailed understanding how people impact on geomorphic processes, more specifically the landscape processes, and how in turn these processes impact on society is an essential contribution towards the goal of a sustainable future. When global community is gearing up for various initiatives, and more recently I would like to mention about the in October IPCC 48 session at Incheon city in South Korea, where we dedicated ourselves for restricting global temperature to 1.5 degree centigrade. Just last week recently concluded the COP24 is another very important initiative taken by the global community in order to improve our understanding. So, first off, I would like to mention what is geomorphology. It is a scientific study of landforms and the processes that shape them. So, how the different processes influencing the landforms. Geomorphologists seek to understand why landscape look the way they do, landform history and dynamics, predict changes through a contribution of field observation, physical experiments and numerical modeling. Linkages between geomorphology, environments and society are mutually dependent. The interlinked fields of major importance for both society and geomorphology from an transdisciplinary social science and human geography perspective. So, when we deal society and societal implications, I think we have to bring several concept of social science perspective, and I also like to discuss with you the how system science approach can play in an important role in this context. The focus is on an ongoing type of arguably worldwide influence of both physical and socio-political system, the rapidly increasing extraction, exploitation, misuse of aggregates, maybe sands and gravel, and the way of addressing related issues from a geographical perspective. So, environmental study requires a very careful geomorphological inquiry. An appraisal shows that what could be gained through a closer cooperation of physical and human geography. So, I think here I would like to also put before you a very important event taken place in July at a global level, when ICSU and ISSC, International Council for Scientific Union, and International Social Science Council, they decided to merge together, because we realize that scientists cannot work without social scientists, and social scientists also cannot work without scientific knowledge. And so, that is why a cooperation between physical and human geography and a consistent search for a geomorphological turn by integrating this issue in emerging International Science Council Future Earth endeavors. As you know, ISC, International Science Council, launched few years back a very important project. It is not known as Future Earth. Future Earth initiative takes care of our future. Future is what? Future is transformation of the past, and it will be evaluation of the present, and using the past and present we can predict for the future. Then I would like to bring before you the essential ingredients of geomorphology. First, continental landscape, landforms and the processes. And in this context, I would like to mention about the different type of surface processes result in materials and landform as a products, like a mountain building process. Look like a climate change study. Climate change, when we deal with the climate change, it is a combination of both natural factors and also the human factor. Human factors are more, anthropogenic factors are more responsible for carbon emissions and global warming, but natural forces are also important. The axis, earth rotation, changing inputs from the sun, changing nature of glaciers, mountain building processes, volcanic activities. These are some of the important natural elements, changing chemistry of water and air. So, landforms, materials, products form a record of our earth surface history. Second important, important aspects I would like to deal, landscape dynamics. It is not a static character, it is a dynamic characters. Like I would like to give you example of tectonic upliftment, continental building, and so we have the erosion or continental destruction. And so that is why seismic characteristics of the Himalaya, Himalayan mountain system, we have a lot of vulnerability not only within Himalaya but also outside the Himalaya, and there exists upstream and downstream relationship. Highland lowland interactive system, because highland, Himalaya as a highland influences the lowland, and so that is why I can tell you the sustainability of Himalaya influences sustainability not only India but sustainability of the whole South Asia. Subsurface deposition like a surface erosion, and as you know, you can see a very much linkage between highland lowland interactive system. Here I would like to bring before you Himalayan, the concept of Himalayan uncertainty, where micro level I would like to deal geographically. Micro level we have rainfall is a very important factor, but when you come to the micro level like a catchment level or the basin level, then deforestation is becoming a very important. Land use change is becoming important, because whatever we have, the all is very much related to the land use change. So, land use change is not only a physical, chemical and biological processes of the earth system, but it also has a very much link with societal responses, people's responses, people's mind or thinking. Now, here you can see these two diagram I would like to put before you from Bhilangna river basin from Uttarakhand, and you can see this the physiographic characteristics. It is a very important aspects of our geomorphology, like a very low elevation, moderate elevation, high elevation, very high elevation, different type of watershed. I think the altitudinal gradient is a very important. Now, I would like to tell you that in a situation of where we have a variation of altitudinal gradients, I think the planning unit may not be administrative, feasible unit may not be administrative unit, but it may be the altitudinal gradient and transects, because vegetation, lifestyle of the people varies according to the altitude. Now, another here you can see different type of altitudinal zones, a distribution between more than 5,000 meters to less than 1,000 meter, and you can find also changes in vegetation pattern, changes in the land use, changes in the soil characteristics according to the altitudes. And so, when we deal with like a sustainability of agriculture, sustainability of horticulture, I think we have to take care of these aspects. Even for looking the sediment load of rivers, I think the such characteristics are very important. Another two map I would like to present before you, again under the umbrella of geomorphology, like a slope map. Here you can see. If you will cultivate more than 30-degree slope, then we are going to have the more and more erosion, and more and erosion means we will have the more sediment load increase of the rivers, and when we will have the more sediment load increase of the rivers, then more flood frequency. More flood frequency means the more and more people will become poorer, and when we have the more poor people, they will have the more dependency on the vulnerable forest resources or the mountain resources. And so, that is why these all are very interlinked. Another right side you can see regional geological map. Geological map also has a lot of giving you characteristics of different type of the rocks, central crystalline, different type of the groups, whether hard or the soft rocks, because these are very much linked with the different type of the existence of different type of disasters. Like I would like to mention avalanches, landslides. These are the two important disasters are very much prevalent in the Himalayan region. What are the driving mechanism? And driving mechanism may be the climate, atmosphere, solar energy, tectonics movement. Again it is a very important part of geomorphology, where I think on that basis geothermal energy, gravity is very important, particularly for looking the fundamental and pervasive force of universe, time average processes like process rates, fast or the slow erosion, time scaling factors, even this all should be analyzed under the broader framework system based science. System, it is a collection of components where components interact and affect one with another, and so that is why the finally landforms and different type of landforms you can find, like arid landforms, in the western Rajasthan area, very different from the glacier landforms or fluvial landforms. So, these are the different landforms. I would like to put before you one of the very important example of mountain landforms here, and you can see through this photograph how temperature sensitive cryosphere, like the glaciated areas, and these glaciated areas are very much linked with the water available in the Ganga region, Brahmaputra region or Indus region. Complex topography, steep terrain, this cultivation in such area largely influenced by such type of the complex topography or steep terrain. Then we have compressed ecological gradients. You can find also the lot of the biodiversity areas. We have various type of the mountain plants and animals with a narrow ecological tolerance. These all are very much linked with the geomorphological status of that area. And so, you can understand from your own perception looking this photograph that the how geomorphology can influence not only the people living in the mountainous area, but people living in the low lying area like Indus Valley, Ganga Valley and Brahmaputra Valley through the highland lowland interactive system. Now, I would like to put before you a very important model of glacier geomorphology here. You can see due to the global warming, now we are living in an era of global warming and we are trying to restrict the global warming of 1.5 degree centigrade from 2 degree centigrade. But recently concluded COP24 has not come with a very concrete a suggestion that how we can eliminate coal based energy sources or the power plant. Regarding financing, we do not have any so far mechanism. For performance evaluation, we do not come on any conclusion. So, I think we have to go very, very fast and hope COP25 will bring a very concrete suggestion so that we can move in the era of direction which may be considered as a better development or sustainable development. Here you can see fragile glacier system, glacier snow melting, formation of glacier lakes, how becoming, then globe. We have not given much emphasis on the globe. Globe has a very much linkage not only the climatic factor, but also the glacial geomorphology. And so that is why we are having the different type of geohazards available in the foothills of the Himalaya. These globe phenomena are very prominent in Sikkim, Himalaya and part of the Himachal Himalaya. And so, we have lot of damage of property and infrastructure. Now, here you can see I am putting before you three important glaciers before you, these are the very not big glaciers, small glaciers retreating snouts of Milam, Dunagiri and Tipra glacier. These are all from the Nanda Devi Biosphere Reserve in Uttarakhand, and here you can find the vacated area due to the global warming, how this glacier retreat is taking place. We collected different type of geomorphic evidences and we found that there is a certainly change nature of the glacier. What will be impact? Short term we will have the more flooding, but in long term we will have a scarcity of the water. So, flooding and drought both phenomena can occur with one very single important factors through retreating of snout of glaciers. Here you can see dead glacier mound and melting from beneath, making the surface collapside an indication of accelerated glacier ice melt. So, how the changing landscape is a very, very important part of geomorphology. This is a confluence of Rataban and South Nilgiri glaciers and abrupt changes in the shape of ablation zone, and this shows indication of accelerated glacier ice loss. Now, I would like to bring before you a very important aspects like applied geomorphology. Applied geomorphology emphasizes geomorphological processes that are societal significance. So, when I use the word the society, environment and society means largely geomorphology is linked with applied geomorphology, including hazard such as flooding and landslides. Increased role of applied geomorphology is due to increasing awareness of environmental decision makers regarding complexity of environmental condition and geomorphological hazards. So, for improving our understanding about the hazards, and when we have the Sendai framework of DRR, we plan in March 2015 the very important initiative, global initiative taken at Sendai city of Japan. It is known as Sendai framework of disaster risk reduction, and India is also a signatory of this framework in continuation of the earlier framework like a Hyogo framework, and then the first one was a Yokohama framework. And more important aspects we are bringing for improving our understanding about different type of the deserts, how we can invest, how we can improve our governance, and how back build better, particularly for preventing the disasters. So, knowledge of geomorphology is very, very important, particularly for disaster risk reduction. Demand from engineers for more information on ground condition for construction purposes. Generally, when engineers work for any project, I think such background knowledge, geomorphological knowledge is very, very important. So, it is a very important aspect of applied geomorphology. Then decreasing level of insularity among geomorphologists, and their feeling that they need to justify their existence in society that increasingly measure value in terms of practical achievements. How practical apply for different type of projects. Projects may be related to sustainable agriculture project, horticulture development, identifying the new township in the hilly area or mountainous area. So, suitability analysis, capability analysis, all based on the geomorphological knowledge. When we are constructing any industry, we need to, even constructing a houses, we need to know about the geomorphology of that area. So, it is also an important part of environmental impact assessment. As you know, this for decision making, now environmental component is important part. What are the importance of applied geomorphology? Near surface landforms, understanding the near surface landforms and hydrogeological system of that area. So, on the surface and then the groundwater also. So, both we understand and analyze under the applied geomorphology. Next one, landscape stability study. When we are constructing materials, so material engineering, geological hazard analysis, this is a very, very important. Third aspects I would like to bring before you, ecologic and wetland study. Direction of water flow, high flow, low flow characteristics, it very much influenced by the topography or the relief features. Then archaeological analysis, historical preservation, this also we can use the knowledge of geomorphology in this context, particularly landscape archaeology, where we have to take the different type of the events in the past, because on that basis we can predict for the future, knowing about the age of the sediment, treating through using the treating, age of the tree. These are the very, very important indicator even for understanding the climate change study. Environmental or resource conservation, different type of the environmental management, even for the biosphere reserve planning, watershed and water resource planning. When we are dealing with the hydel projects, it is not easy to find a very suitable site for that. Sometime many people used to suggest that we need the small hydro is more better, but it is not easy to find the small hydro, and different type of the gradients are very, very important in this case. When we deal with agriculture, India largely known for the agricultural economy, so erosion related study, soil conservation analysis, even terrace agriculture. You can't find terrace agriculture in other mountain systems. You can't find in Elbrus, can't find in Alps, Andes. You can find only in Himalaya, a very typical system. Since century, people are experiencing this, and they were aware for preserving the land from erosion processes, and where knowledge of geomorphology can very much helpful also for planting different type of the plantation. Here I would like to bring before you, you can see here the how I am taking one example of landslides. Here you can see increased soil erosion, surface erosion and sediment load, how these are the very, very linked. We have high flow season and low flow season. High flow season, a very high energy, even big boulders, rivers, transporting from the high Himalaya to the Ganga Valley or the rivers, and so that is why sediment load coming up, and we are also in flood frequency getting the more and more flooding in the low lying area. So these are very, very linked. Landslides are the result of both natural factors and the human factors. Human factors are the more, but if you will go to high Himalaya, even you can find the landslides where there is no human interference. So this means that it is not only a natural phenomena. No doubt road construction, grazing, these are the very, very important aspects. So when you are constructing the road, knowledge of geomorphology is very, very important in this context. Earlier, for constructing the roads, for leveling, we use the dynamite and on, and so that is why we making the more and more unstable, mountain slopes, and so these are subject to the lot of erosion, rock falls, and variety of disasters and hazards. So different type of the soil types, rock types, these are the very, very important As you know, we have the generally Himalaya is considered as a seismic zone. So, this makes the more and more vulnerable. So, vulnerability, exposure, risk, these are the three important elements and very much linked with we can improve our understanding by bringing knowledge of geomorphology. Here you can see risk assessment of glacier lake outburst flood. Glacier exists in the upper zone, avalanches occur, and avalanche is influenced by also the climatic factors. Then we have the vacant space due to the glacier receding. Then lakes are being formed, and then moraine dams are being created. Sometime due to the very high energy during the high flow season, these dams are burst, and it may cause a big problem in the low lying area to different type of developmental activity. So, cross section of this globe and risk assessment, but here while evaluating the risk, we have to see also the macro level risk, micro level risk, the moderate or medium level risk, human risk, natural risk. So, we have to integrate, we have to do an integrated assessment. Knowledge of geomorphology helps in improving our understanding about such type of the problem. Through this diagram, I would like to bring before you the different type of geomorphic risk element. First, I would like to take the hazards, and as you know, hazards are extreme events, and then disasters are very much linked with these hazards. But what is at risk? Everything located in the flood zone. People, crop, livestock, weak buildings, their contents, local economy is very, very important. I am giving you one example. Suppose if you are doing agriculture in the steep slopes, then you are also inducing more and more flooding in the low lying area and influencing the lot of characteristics of the rivers. Like take earthquake, weak geological structure, high seismic activity, existing of seismic zones, central thrust, existence of central thrust, these are the very, very important phenomena. Tsunami and cyclone, these are, what is tsunami? Tsunami is a earthquake induced sea waves, and so that is why everything close to the coastal area, the location of the coastal area, topography as the coastal area, geomorphological hazards available in the coastal area, crop, livestock, people, combustible roofs, water supply, these are the very, very important aspects. Take the case of landslides. Everything located on or at base of the steep slope, this may be at risk. Cliff tops, road and infrastructure, buildings on shallow foundation, these are the and so that is why knowledge of geomorphology can help in bringing more and more risk mitigation. Drought, arid and semi-arid landscapes, we have different impact in arid area and different impact on semi-arid area. How the climate change taking place between arid to semi-arid to arid, and subtropic to the semi-arid, critical aquifers, groundwater availability, even sometimes the quality of water. Climate change also influence the quality of water. These are very much linked. I would like to put before you a very important geomorphological model for landslide detection here, and you can take like a satellite imagery interpretation before and after the event we can do. LIDAR data can be used, DEM can be created, digital elevation model. We can take the geomorphological knowledge like slope, curvature, OHM roughness, topographic wetness index, statistics of landslides and threshold of selected geomorphic parameters, even for the knowledge about the old landslides and river buffer, hydrological and geological data. These all can be incorporated in accuracy evaluation, model prediction for landslides, and then we can validate the results. Here you can see through diagram I am trying to put before you how topographic information useful for disaster emergency. These very important, like we have the disaster response force. Disaster response force can use the topographic knowledge from the topographical sheet prepared by the Survey of India, and they can improve their understanding about data for vulnerable topography, where we have the more flow of the water. If so much increase in the sediment load, how much area will be covered under the flooding, and how the rescue operation can be done, where safe shelter can be established. So, these are the information I think our disaster involved policy makers, coming from like NDMS, National Disaster Management Authority, they should have a proper knowledge this, and those who are implementing this, particularly first responders. I would like to tell you disaster response force, they are the first responders, and such type of geomorphological knowledge is very useful. So, it has a larger implications for saving the people. We have the different type of hazard map portal site prepared by the Bhuvan, directly you can use. I would like to bring before you another important branch, what it is known as geohydrology. Generally geologists, they study this geohydrology, this branch of the earth science which deals with the occurrence and movement of subterranean water. Generally it is called the hydrogeology. It is a very much interdisciplinary in a scope, that it involves the application of physical, biological and even the mathematical sciences. So, geohydrology integrates the knowledge coming from physical sciences, biological sciences and mathematical sciences. It plays a very important role in the wide range of issues involving groundwater, such as drainage of excavation, sites. It is very when you are doing the archaeological excavation, I think this knowledge of groundwater very important. Subsurface construction, what is the groundwater, site preparation, development for urban area, even for industrial sites, most important drinking water supply. These are the very important area where the knowledge of geohydrology through geomorphology can be very useful for our planning purpose. These are the more relevant today, especially in India, where over exploitation, declining groundwater levels and groundwater quality issue is affecting the lives of most of the population living in the undulating area or the hilly area. Here you can see cross section sketch of a typical ground water flow system showing the relationship between an unconfined and confined aquifer. So, you know, this knowledge how the aquifer is confined or unconfined, we can estimate the water table. Other type of hydrological elements are also very, very important, you know, knowledge. And so, the even for artesian boreholes, for the confining cover, the groundwater planning, irrigation planning, I think the such type of the knowledge is essential. Ground management cycle, through diagram you can see that how the ground management, we have the information needs, monitoring strategy we have to do, we have to develop the network design, we have to collect the data, particularly the sampling, analysis, then we can do the data handling, data analysis, report preparation, and then information utilization can be very helpful for the societal implications. So, ultimately we will start with geomorphological knowledge, try to use the environmental study and the interdisciplinary characteristics of environmental study, and then we can help for societal planning. Dynamics of environmental system, the impacts and the consequences of earthquakes mainly manifested geomorphologically in landslides and associated features are made even more and more disastrous due to the dense population. So, where we have the more dense, if we can superimpose the dense population, distribution of population and related human activity, we will have the better idea about the dynamics characteristics of environmental system, how can influence our geomorphological characteristics and hazards. Sediment yields from river catchments may be indications of landslides activity, along with river channel change and several, you know, other geomorphological features, sediment deposition in the lowlands where there are diverse land usage and economic activity exacerbates damage caused by such type of the processes. We have to see also the seasonal characteristics, unpredictability of sediment yields manifests also in the coastal geomorphology, especially because settlement and economic activity are concentrated in these regions, resulting in the both urban and rural development challenges. So, in both situations, for various rural developmental activity and urban development activity, the knowledge of geomorphology is very, very important. All these phenomena are considered as integral to the dynamics of environmental system. So, it is very much linked. Geomorphology, environment and society, landslides, river channels changes, coastal changes represent three sides of an environmental triangle, need understanding and challenges to be mitigated. In this context, I would like to tell you that new area of science like remote sensing imagery, in particular aerial photo and the field observation records are employed to demonstrate how the dynamic Indian environment can better be understood in relation to the geomorphological processes and features, including characteristics of landslides, river channel, and the coastal changes. Geohydrology and environment are very much linked. Both are intimately connected. Calculation of the movement of dissolved contaminants are very one can advise to the design of on-site decontamination and the protection of drinking water supply, drainage system for efficient control to layout of waste disposal sites, assessment of system for equivalent thermal storage energy storage is also another area where we can do. Here you can see the basin map of India, where we have the macro basin, where we have the micro basin. These are very important knowledge of geomorphology. If we can relate and superimpose landform on these maps, like a base map of India, of this river basin map, it is possible to predict also the sediment loads, where we have sediment load. Knowledge of societal knowledge, if we can superimpose, we will be able to know how this influences our all river system. So, river systems are getting lot of impact coming through variety of activity in the upper catchment area. Now, you can see here drainage characteristics, is different type of stream order. This is a map from Bhilangana river basin of Uttarakhand, drainage density map. Such type of the maps are very important, where we have the more very low density, high density, and so here I would like to bring before you, we can even quantify these qualitative factors like high, medium, low, and we can transform into the quantitative factors. So, we can use in the multi-criteria analysis. Ecohydrology is considered is a very new paradigm in geomorphology. You can see it has arisen from the hydrology and ecology. It was first propounded, postulated in Dublin in 1992 at the International Conference on Water and Environment, and it suggests a new watershed approach. And country like India, where watershed planning is becoming a very important for decision making. No longer we can take administrative unit like block or tahsil as a planning for development. I think these are the very important. So, eco-hydrological knowledge is very important, particularly understanding the freshwater ecosystem, water quality, different type of biological processes, how the temperature, light, nutrient availability, water mass dynamics, they are influencing our societal and environment. The issue of water quality at the basin scale cannot be resolved without improving our understanding of geomorphology, because here we need also not only the knowledge of hydrology, but biological processes, biota, and three main objective of hydrology, like a hydro system, aquatic system, then climatology, hydrology, water chemistry, toxicology, biology, and these all are very important for the humankind. Integration of computerized model based on this knowledge, prediction of changes in the hydro system, these are the simultaneously we can analyze using different type of the hydro climatological channel and biological study. Here you can see through this diagram how this climate change, environmental factors like climate change, water management, land use change, irrigation and water transfer, release of domestic waste, how they influence through major impact of the global issue. And one can see a very close relationship between surface groundwater system in oasis and related issues, particularly the water harvesting structure in the dry areas. Ecohydrological approach, increasing absorbing capacity of the ecosystem, and so that hydrology and biotech knowledge both can be integrated in this framework of ecohydrological approach. We can take climate forcing, topography, where geomorphological knowledge is very important, water balance, plant mortality, plant dynamic, and a spatial interaction. Here you can see multidisciplinary approach of geomorphology, where hydrologists, bioengineer, ecologist, other they can act and develop different type of societal implication for improving our societal prosperity. Here you can see the ecohydrological concept of the restoration of eutrophic shallow reservoir for applying various type of eco-biotechnology, where we can have retention capacity in the catchment, trapping, where we have more sedimentation, biofiltration, transformation. These are very linked with the knowledge of geomorphology. So, application of ecohydrology is many: water resources to the hydropower development, bioenergy development, effects of flash flood in Vilangna. You can see here how the hydropower station, where the knowledge of geomorphology is very important, because even low lying area, what will happen, what type of even sometime in the coastal area, aquaculture development, biodiversity knowledge is very important. New approaches of hydrology integrates the information, knowledge and wisdom, and so we integrate here the water science, ecology, and then the sociology. So, this topic, the linkages between geomorphology, environment and society are the foundation of development in any society or any country. You can see this how area in India are liable to the flood, and these are very much linked with what is happening in the upland, in the instability in the Himalayan area, and one can see here red mark, all are the flood affected area, but one can see very much relate with the land use change in the upper part of the area. Here you can see this IIT Kharagpur, how they have taken GIS based flood risk evaluation for the Kosi here, distance to channel, elevation, land cover. Role of Anthropocene is very important, particularly for understanding this and societal application. Here you can see how people are adapting coping different type of the disasters like a flood, and they are applying the local techniques, water in the third desert, collection, traditional water sources. These are the very rainwater. Finally, I would like to tell you this, even sometimes geohertz are very much linked with the knowledge of geomorphology. Finally, I would like to conclude that we have to do the mapping of landform, resources and hazards, establishing rate of geomorphological change by direct monitoring, establishing cause of environmental change, post construction assessment of engineering SPing development, and finally we can predict the future changes based on the geomorphological knowledge. Thank you very much.